Hello, this lesson is all about statistics in analytical science. In analytical chemistry, numbers are everywhere, from repeated measurements to experimental results. But numbers alone don't mean much until we organize and interpret them. That's where statistics comes in. It helps us make sense of data and judge its reliability. For introduction, think about this. The scores of the students in the prelim exam are 90, 95, 92, 90, and 90 out of 100. If you're asked to think of a score that would best represent the given scores in the exam, what score would it be? Yes, very good. I think you are thinking about the average of the scores of the students. That's a correct answer. So one of the first things we look at is central tendency, the values that show us the center or typical result in a set of data. Central tendency, the word central means middle or center. It's a kind of metrics in statistics that summarize a dataset by identifying a central point or typical value. There are many uses of measures of central tendency. First one is to summarize data, as what we've done in the previous slide. Then we can also use the measures for comparing results or to identify typical values, like values that oftentimes occur in a set, or to detect outliers or numbers that are so far from the middle. And lastly, for estimation of values. There are three primary measures of central tendency, and they are mean, the mode, and the median. The mean is the arithmetic average. The mode is the most frequent number, and the median is the middlemost value. This is a diagram showing you the three examples of central tendency. Let's talk about the mean first. The mean is calculated by summing all the values in a dataset and dividing by the number or values. This is the most commonly used measure of central tendency and is suitable for interval and ratio data. The mean is sensitive to outliers, however, which can skew the results significantly. Mean simply means the average of all datasets. The formula for calculating the mean is x bar, that means the mean, is equal to sigma, that is read as summation of, x meaning each of the value or element in a set, divided by n. The n is the number of values. Example, a researcher is analyzing the concentration of a drug in a pharmaceutical formulation. They perform 5 replicate analysis and obtain the following results: 12.45 milligrams per ml, 12.51, 12.48, 12.53, and 12.47. Calculate the mean concentration of the drug in the formulation. So all we have to do first is get the total of all the measured values. So we add them all. The answer to the sum of all the values is 62.44, and then divide them by the number of total observations. So there are 5 observations or 5 measurements. So 62.44 divided by 5 is 12.488. Okay, following the rules for significant figures, since 5 is, this is an exact number, so it's not included in counting, but the measured values are included in counting. There are 4 significant figures in 62.44, that's why the answer is 12.49. Thus, the mean concentration of the drug in the formulation is 12.49 milligrams per ml. The next measure is called the median. The median is the middle value when a dataset is ordered from least to greatest. If there is an even number of observations, the median is the average of the two middle numbers. Median is useful for skewed distributions or when outliers are present, as it is not affected by extreme values. It is used with ordinal data, those that rank values; interval data, those with exact intervals or exact difference; and ratio, this is combination of ordinal interval plus a true zero. So how do we find the median? To find the median, First, we must order the dataset from smallest to largest. Arrange from smallest to largest, in short. Next one, if the number of observations is odd, the median is the middle number. If the number of observations is even, the median is the average of the two middle numbers. Example, a chemist is measuring the concentration of a pollutant in a water sample across 6 different sites. The concentrations in milligrams per liter obtained from the sites are as follows: 5.2, 4.8, 5.5, 5.0, 4.9, 5.3. Calculate the median concentration of the pollutant in the water samples. So in order to find the median, we must order the data first from smallest to greatest number. Arrange the concentrations in ascending order. So the arrangement goes like this. The least number or the least value is 4.8 and the greatest value is 5.5. And after that, count the number of observations. If you count them all, there are 6 observations from 4.8 to 5.5. And 6 is an even number. If the number of observation is even, we must take the average of the two middlemost values. In a set that has 6 values, the middlemost value is the third and the fourth value. So the third value here is 5.0 and the fourth value is 5.2. All we have to do is get the average of the third and the fourth value. So 5.0 plus 5.2 divided by 2 is 10.2, divided by 2 is 5.1 grams per milliliter. So the median concentration of the pollutant in the water samples is 5.1 milligrams per liter. So this measure is particularly useful in analytical chemistry as it provides a central value that is less influenced by any potential outliers in the dataset, unlike in mean, allowing for a more accurate representation of the typical concentration in the samples analyzed. So this is just one of the problems that you might encounter when there is an even number of observation. If the number of observation is odd, for example, let's take 5.5 out of the set from 4.8 to 5.3, then the middle value is 5.0 because the middle value in a set of 5 numbers is the third value. Okay, I hope that is clear for you. And the last measure of central tendency is the mode. The mode is the value that appears most frequently in a dataset. Mode can be used with nominal, those numbers that can be used to categorize and name objects. Ordinal, this is for ranking again. Interval with exact distance. And ratio, the combination of nominal, ordinal, interval plus a true zero. A dataset may have one mode, we call that unimodal. Or more than one mode, we call that bimodal. Or more than two, we call that multimodal. Or no mode at all if all values are unique. This is useful for categorical data where we want to identify the most common category. So how do we know the mode? Well, it's easy. You just have to identify the number that appears most frequently. So, for example, for the dataset 2, 3, 4, 4, 5, the mode is 4 because it appears twice and it appears most frequently among all the numbers. Another one, a biochemist is studying the concentration of a specific enzyme in different samples taken from a biological fluid. The concentrations in units of enzyme activity measured from 12 samples are as follows: 5.2, 6.1, 5.2, 7.3, 6.1, 8.0, 7.3, 5.5, 6.1, 7.3, 8.0, 5.5. So determine the mode or modes of the enzyme concentrations. So it seems that there are many repeated numbers here. So in order to avoid confusion, we must organize the data first. You can have a list for all the numbers and the times they occur in the set. You just simply count the frequency of each value. For example, 5.2 appeared 2 times, 5.5 appeared 2 times, 6.1 appeared 3 times, and 7.3 appeared 3 times, and lastly, 8.0 appeared 2 times. So you just simply identify the highest frequency. So the values with the highest frequency are 6.1, which appeared 3 times, as well as 7.3, the same. Since 6.1 and 7.3 occur most frequently, then they are the modes of the dataset. In other words, the set has bimodal or is bimodal because there are two modes, two numbers that appeared most frequently. Those to summarize, central tendency are arithmetic mean, median, and mode. The mean is simply the average. The median is the middlemost value when the sets or the numbers are arranged in order. Mode is the most frequently observed value. So knowing the center of our data is useful, but it's only half the picture. Two sets of measurements can have the same average, yet behave very differently. To really understand data, we also need to look at how spread out the values are. That's what dispersions tell us. So the next part of this lesson is all about measures of dispersion. Measures of dispersion, also known as measures of variability or spread, are statistical metrics that describe the distribution of values in a dataset. There are many measures of dispersion. The most common ones are range, variance or sample variance, and standard deviation. Let's talk about the range first. The range is the simplest measure of dispersion and is calculated by subtracting the smallest value from the largest value in the dataset. It provides a quick estimate of the spread of the data, but it is sensitive to outliers and doesn't consider the distribution of values between minimum and maximum. It only tells us the maximum and the minimum value in a given set. So range is calculated by subtracting the maximum and the minimum value. Example, what's the range in the given set of measurements? 5.0, 5.1, 4.8, 6.0, and 5.0. Since 6.0 is the largest or max value and 4.8 is the minimum value, we just simply subtract the two numbers. So 6.0 minus 4.8 is 1.2. Therefore, the range of this set is 1.2. But among the measures of dispersion, the most common one that is used in the analysis of data is the standard deviation. The standard deviation is the square root of the average of squares of the differences between each score and the mean. It measures the average squared deviation from the mean. It simply means how far, on average, the values are from the mean. If the deviation is big, it means on average, the scores are far from the mean. So how to solve for the standard deviation? First, solve for the mean of the set of numbers. We already know how to do this in our previous lesson. Then subtract the mean from each value to get the deviations. After that, square each deviation. After that, sum the squared deviations or get the total. After that, divide the sum by the number of values and square the square root or extract the square root of the answer. The formula for standard deviation is standard deviation is equal to summation of the square of the difference of each element in the mean divided by the number value in the dataset. So we'll just show you how to do it after this slide. Let's just talk about sample variance first because these two are related. Only one step is different. The variance is just the square of the standard deviation. If if we have solved already the standard deviation, all we have to do is square our answer to get the variance. In other words, we don't take the root of the answer for our standard deviation. The last step in our standard deviation is omitted. So for example, a chemist is measuring the concentration of specific analyte in 5 different samples. The concentrations in milligrams per liter is obtained from the samples. Are as follows. Sample 1 is 10.2, sample 2 is 11.5, 9.8, 10.5, 11.0. Let's calculate the variance, standard deviation, and standard deviation of the analyte concentration. So first, it's better to make a table for easy tracking of numbers. So in your table, you can have a column for each of the value. The second column is for the mean. The third column is the difference between each value and the mean. And the fourth column, the last column, is the squared of your answer in the third column. So first, you have to solve for the mean first. The mean of 10.2, 11.5, 9.8, 10.5, and 11.0 is 10.6 milligrams per liter. For the third column, all we have to do is subtract each of the given number and the mean that we just have solved. Okay, if you've already solved or calculated the difference between each of the number and the mean, for the last column, we must square that difference. So example, 10.2 minus 10.6, that's negative 0.4 for the first row. Then if you square that value, 0.4 squared or negative 0.4 times negative 0.4 is 0.16. We would expect that all of the numbers here are positive because squaring a number is just simply multiplying it to itself. So after that, we have to take the total or the sum of the fourth column. So you have to add 0.16, 0.81, 0.64, 0.1, and 0.16. The answer to that is 1.87. The last step is, the two last steps, is to divide 1.87 by the number of observations or the number of elements or measurements. We have 5 measurements: 10.2, 11.5, 9.8, 10.5, and 11.0. So 1.87 divided by 5, for standard deviation, we just have to divide it by 5 first. The answer is 0.374. Then take the root or square root of 0.374. The answer is 0.612. So that's the standard deviation. If you want to solve the variance, all we have to do is we do not take the root. We do not apply the square root of our answer 0.374. That is already the variance of the given numbers. So there you have it for the standard deviation and variance. You can have a practice using measure substantial tendency. This is seat work 1. You can copy this, and for the next slide, this is for the measurement of dispersion. You can also copy this, practice in your notebook.